Jai Hind everyone, and today we will start the first lecture of our series Signals and Systems. That is a classification of systems. Uh, what are systems? If we go about systems defined that any physical component, physical or chemical or any environment where if we given any input, we have get a response or output. For example, let's take a very simplest example, a tree. Okay, let's take an example, a tree. What a tree do? It will take out the CO2 from the environment and given out O2. So a tree is what? It's a kind of a system where the input is the carbon dioxide and the output is the oxygen. Now, if we get out from the physical environment to the electrical environment, suppose we have a RLC circuit. This is V. And we get a current, and through each component we get a particular voltage. So it's a electrical environment. Okay, so a system is, if we draw the block diagram of a system, then whatever a system is, it's an environment in which if we given out any input abbreviated like xt or xn, we get a output, that is yt or yn. So this is what we say a system. Now if we classify a system, then our system has been classified based on the different categories. Like the first category is, we get the classification of the systems. The first category is depending upon the types of signals we are dealing with, that is the continuous time system and discrete time system. That is the first category. Then depending upon the relation between the input and the output, we have another kind of systems, that is a causal and non-causal systems. Third category, again depending upon how the input and outputs can be related, we have a linear and non-linear system. Then fourth, depending upon the time relation between the input and output, we have time-invariant and time-variant system. Then we have invertible and non-invertible system. And the last category would be stable and unstable system. So these are the classification of the systems based on what kind of signals we are dealing with, depending upon the relation between the input output, and what kind of relationship if it is a depending upon time, it is depending upon the behavior. So let's move with the next uh, part, that is first what the classification of continuous time and discrete time. Continuous time systems means where uh, if we change the color, continuous time systems are those systems where a signal is continuous with respect to time. For example, if we have a system, then xt, that is the input, and the yt, that is the output, both are continuous in nature. Okay, for example, let's take a simple example. For example, a relation between the current and the voltage in RLC circuit or in RC circuit, whatever the you take. Suppose there is a RLC circuit. This is the voltage, this is the current, and both is continuous in nature. So this is a kind of continuous time system. Now moving to the discrete time system. Discrete time systems are those where the input and output signals are discrete in nature. It's an obvious thing. If a signal is discrete, then how can you apply in a continuous time format, right? In a continuous system, because suppose there is a resistor or there is a capacitor, and you are applying a voltage in the interval. Suppose in one pulse, then another pulse, then another pulse. It will be gives you a voltage that will be discontinuous in nature. So that will be something not um good for the behavior for the system also. So for the discrete time input and output signal, we should have a system that is in a discrete in nature. Okay, so here we have a systems which will be discrete and in nature, and we have x and we have y. Now, for example, suppose we have a systems where yn is given as n into un, okay, plus or you can say minus. Let's take a minus. Minus n minus 2 un minus 2. Okay, so this is something a system. So what the system do? The input is the yn, the input is un, and the output is yn, and the system will multiply it with the n, its counterpart, and then subtract the systems like this. So this is a kind of what we have a systems. Okay, so moving to next part, that is causal and non-causal systems. Causal and non-causal systems. Second category. Causal systems are those, we write it, causal systems are those in which the output is depend only at present and past value of input. Okay, so causal systems are those systems in which the output is depend only at the present or the past value of the input. For example, suppose yt is equals to xt plus xt of minus 1. Okay, so if t is equals to 0, at t is equals to 0, y of 0 is equals to x of 0 plus x of minus 1, or at t is equals to minus 1, y of minus 1 is equals to x of minus 1 plus x of minus 2. At t is equals to 1, y of 1 is equals to x of 1 plus x of 0. So you see, in all these three, the output, that is y of t, or some depending upon the value of t, it will always depend upon the past value. This is the present value and this is the past value. This is the present value and this is the past value. This is the present value and this is the past value. Okay, so the output is depend only the present and the past value of the inputs. So this is what we have a causal system. Similarly, for discrete time also, if yn is equals to x of n plus x of n minus 2, then this is also a causal system, causal discrete time system. Okay, so this is what we have a causal system. If we move further to what are non-causal system, then let's see what are non-causal system. Non-causal systems are those in which output is depend on future value of input as well. Okay, future value means, for example, if yt is equals to x of t plus x of t plus 1 minus x of t minus 2. Suppose I have a system like this where xt is the input and yt is the output. Okay, and this is the system has given this equation. Okay, now at t is equals to 1, what we have, y1 is equals to x of 1 plus x of 2 minus x of minus 1. Okay, and at t is equals to minus 1, y of minus 1, x of minus 1 plus x of 0 minus x of minus 3. So what we have, this is the present value, this is the future value, and this is the past value. So we have all the kind of value here. So present, future and the past. So if the system is depend upon the future value also rather than the past and the present, then that system is kind of a non-causal system. Okay, let's move forward. I forgot to mention one very important kind of system, that is static and dynamic system. Okay, so what are the static system? Static systems in which the output is depend only on the present value of input. Okay, for example, suppose yt, if xt is a 6 input in a system and yt is the output, then yt is equals to e of xt. Okay, so this is what at t is equals to 0, that is y0 e of x0. So this is what it is, the present value. This is also a present value. Yt is equals to cos of xt. So y0 or y1 is equals to cos of x1. So when the output is depend only on the present value of input, then that is a static system. Or if we want to connect between a static and the causal system, then all static systems are causal systems, but not vice versa. Means all causal systems are not a static system, because causal systems are depending upon the past value also. So that will not benefit the static system definition. Moving to next part, that is the dynamic system. Dynamic systems are like if the output is depend upon future and past value of input as well, then those are dynamic system. For example, that is yt is equals to xt plus x of t square, then it is a dynamic system. Okay, for t is equals to 2, y of 2 is equals to x of 2 plus x of 4. So this is the present value obviously, but this is the future value. So it is a dynamic system. So dynamic system in which the output is depend any values, present, future, past. Okay, so not only present but future, past as well. Then the system is dynamic system. Okay. Okay, moving to next part, that is we have linear and non-linear system. Very important systems, linear and non-linear. What are linear system? Systems that obeys a superposition principle. For example, system that obeys a superposition principle. For example, what are the superposition principle? The principle which conclude two properties. One is the additivity property, additive property. What additive property said? That if xt gives in a system we got yt, that is we got a yt, x1t, sorry, x1t got a y1t, hmm, use eraser. Okay, so x1t and x2t, the system as y2t. Okay, then if we give x1t plus x2t in a system, it gives out the value y3t, which is equals to y1t plus y2t. So this is the additive property of a system, and second is the homogeneity property. Homogeneity property said that if a, that is any arbitrary constant, that is, it can be a complex number also. So any arbitrary constant, if multiply with the xt, we got the same arbitrary constant at the output, give out a by t. So this is the homogeneity property, and that is the additive property. Moving to next part. Thank you for this time, and we will continue this lecture for the next uh, series, for the next lecture series.